Okay, and once again, good evening to everyone. Thank you for being here to attend a review in differential equations. So I'm going to explain to you solve problems in differential equations, especially I'm using the method separation of variables. So these are just selected problems that I felt that you need to be familiar or need that so I felt that you need to see these problems, although maybe some of you have already seen this. So maybe to those who have not seen problems like this, or how to uh, what's the right approach for solving these problems. So these are already solved problems, so I'll just explain the step by step, or if you have questions along the way, so you can interrupt or you can unmute your microphones and ask me. Okay, so this is for you guys. So if you have any questions or clarifications, don't hesitate to ask questions. Is that okay? This is a review, so I'm here to help you. Now, the first problem here is actually finding for the particular solution. So as you can see, there is a, of course, there's a condition here. So the given equation is a first order DE. And the only method that I have taught you is separation of variables or variable separable. Okay, wait for a moment. There's ano pa yatang papasok. There's on the recording. Okay, so the variables here are R and T. So okay, we'll separate the variables, cross multiply. So we have dr, okay, over R. And on the right hand side, you just retain the constant -4 here, -4, and the variable t on the right hand side. So that way we're able to separate the variables. It's just very easy. But what I want to show here is the resulting, solution. So once that you have separated the variables, now you integrate. That's the next step. So integral of the left-hand side is ln of r, and on the right-hand side, so the rule is that if you have a constant there, so you may put the constant before the integral symbol. So you have copy -4, and then you integrate this one, t dt, and the integral of t dt is t squared over 2. Now what happens here is that if you divide -4 by 2, it will become -2, right? So you have -2 t squared plus, supposedly you just write plus c arbitrary constant, right? So since we are to simplify this, and so we need to make this ln of c, just like what I'm doing in my solution. So now that we can see that, okay. So what happens here is that this first term is actually represented by, of course, you have ln also here. And this ln of e raised to -2t squared is equal to -2t squared. Okay, this is another way of writing this or simplifying this term. Now that every term has ln, okay, so you can combine these, the property of logarithmic functions allows you to rewrite this side of the equation into ln of c times e raised to -2t squared. Now that both sides of the equation have ln, so we take the inverse or anti-ln of both sides of the equation. That's why we have r equals c times e raised to -2t squared. So this is the general solution, okay? So you know, a general solution is a solution of a DE that contains arbitrary constant. Clear? Now, now the next step is for us to apply the given condition. So t is equal to 0. and r is equal to r sub 0. Okay. Now we plug in these values to the general solution. So we have r becomes r sub 0, and then on the right-hand side, you have c, e raised to minus 2. The value of t is 0, so 0 squared is 0. 0 times minus 2 is 0. E raised to 0 is equal to 1. That's why your r sub 0, your c is equal to r sub 0. Finally, you have your particular solution, which is r equals to r sub 0. So r sub 0 usually is the initial, the value of the variable initially, okay? The value of the parameter at time is equal to 0. So if you have recalled yung ating lesson about the elementary applications. So here you have r sub 0 times e raised to minus 2t squared on the right-hand side. So this is your final answer to this given problem. Now, do you have any questions? None? Okay, so if you have no questions or clarification, then we go to the next problem. Okay, here we have 2xy times y prime equals 1 plus y squared. And you have a given condition, x is equal to 2, y equals 3. Wait for a moment. Okay, so now what we will do is we try to separate the variables. Okay, so we put y with dy and x to dx. So we change y prime into a Leibniz notation format or notation, so dy over dx. And then we multiply both sides by dx para maging differential na sila. Okay, now. And then we also want to eliminate x here. So we divide both sides by x. And on the right-hand side, so you want that the function or the variables involved here is x. So you are going to divide both sides too by 1 plus y squared. So therefore, the resulting equation is 2 times y dy over 1 plus y squared, or do cross multiply, so ganun lang yun, equals dx over x. Now, as you can see, the left-hand side is the variable y, and on the left-hand side is the variable y, and on the right-hand side is the variable x. Now we can integrate both sides of the equation. Okay, so we integrate this one. So we check the formula, the integral of du over u. So if this is your u, and you differentiate this, the numerator should be the differential of the denominator for you to be able to utilize the formula ln. So if you differentiate this, this will give us 2y dy. And as you can see, the numerator is 2y dy. So that's why the resulting integral is ln of 1 plus y squared. And on the right-hand side, you have the integral of dx over x, which is equal to ln of x. So we add the arbitrary constant on the right-hand side, or to the independent variable in the equation. Now, so we put, instead of writing plus c, so we make it ln of c, and then we simplify. Since each term has ln now, and we can combine these two terms into one term, okay, following the rule in the logarithmic, or the property of logarithmic functions. So ln of x plus ln of c is equal to ln of c times x. Now that we have ln on both sides of the equation, so we can take the anti-ln, or the inverse of this, which is exponential. So e raised to ln of this function and e raised to ln of this function is equal to 1 plus y squared equals c times x. Now this is now our general solution. Since we are given conditions, so we need to determine the value of c so that we will have our particular solution. Okay, so it says that when x is equal to 2, the value of y is 3. So we plug in these values to the general solution. So we have 1 plus 3 squared equal to, the value of x is 2, so you have 2c. So 1 plus 3, okay, the 3 squared is 9, right? 9 plus 1 is 10, 10 divided by 2 is 5. So the value of arbitrary constant c is 5. So we now have the particular solution. Plugging this value of c to the general solution will give us 1 plus y squared equals 5 times x. And then if you are asked to solve for y, so you can put the equation into this format. You transpose 1 to the right-hand side. You have 5x minus 1. And yeah, solving for y. So for us to eliminate the exponent here, so we take the square root of both sides of the equation. So we have y equals the square root of 5x minus 1. Okay, so these solutions here, you can see maybe if you're not asked to solve for y, so maybe you can see one of these solutions in your exam, maybe. So you might be asking, okay, so what's the real answer here? So if you have taken quiz number 1, so there are, you know, there are items that um, that you may be that you might have encountered that are similar. Or maybe you did not read the direction carefully. That's why. Or so be careful, or you must check each choice. Maybe those items have, are distinct um, or distinct terms, or distinct in nature, or different from the other. So that's why. So if you are given this problem, for example, in your exam, and then um, it's actually all or nothing multiple choice type, and then you have forgotten that this solution can be expressed into this form and also this form. So you have to make sure. So I might be giving an all or nothing multiple choice. So I'm telling you this because you're here, you're attending this review. So I might be giving an exam like that. Okay, clear? Some variations to show your solution. Any question here, guys? Do you have any questions? None? Now let's proceed to the next example. So we still have how many? 1, 2, 3, 4, 5. Okay, now the given problem is, so you might be seeing this as very simple, yeah, very simple problem. So let's see. So you have a given condition here. Now, xy squared dx plus e raised to x dy is equal to 0. So this differential equation is in the format m dx plus n dy, where m is the coefficient of dx and n is the coefficient of dy. Now, our objective here is to solve the particular solution since you are given conditions. So when x approaches infinity, y approaches 1/2, or y is 1/2. Okay, so here, as you can see, naka-factor form naman siya. I mean, naka-product, di ba, yung coefficient ni dx. So you can be able to separate this one. So what we will do is we divide both sides by what do you want to eliminate in the first term? We don't want to see y there, di ba, or y squared. So divide both sides by y squared. And you also want to eliminate a function of x in this term. So you divide both sides by, or divide the entire term, or the entire equation by e raised to x. That's why you have y squared e raised to x divided, or the entire equation by this factor, okay, y squared, or this product, y squared e raised to x, y squared e raised to x. So having divided the entire equation by this product, so we have the resulting equation x dx over e raised to x plus dy over y squared. I think this is familiar to you. Okay, so integral of, so what we did here is we put this e raised to x up, and it means that the exponent will change its sign, right? So this will be x times e raised to minus x dx plus, if you also want to put this up, the sign of the exponent will change. So that's why we have y minus 2. So pure function of x, a pure function of y, now we can integrate. So this can be solved using integration by parts, as you can see for this integral. So we let u equal to x. If you remember integration by parts, and your du here is and your dv, so u times dv, that's actually integration by parts. So your u is dx, and you are to differentiate this one. And for your dv, so you are to integrate that. So dv is equal to the integral of e raised to, no integral sign here. So e raised to negative x dx. So you integrate both sides of the equation, and then you have v, wait a moment. I'm going to, oh, I did not see. It should be integral, okay. Anyhow. Okay, now that we have the value of v and du, so if you remember integration by parts, the integral of u times dv, guys. Integration by parts, integral of u times dv. So that is what? U times v minus integral of v times du. Okay, so you have your u is x, so you put it in here, x, okay, x, and then what is your v? Your v is minus e raised to negative x. So you have here minus x times e raised to minus x is your first term here, and then minus integral of v times du. So minus v, your v is negative, so minus minus, you have positive here, and then integral of, so here is negative x, your du is equal to dx. That's why you have the equivalent of this, or of this integral. So you have the first term minus x e raised to, let me clear first the drawing. Okay, so we have here the first term, and then you have the second term. If you integrate this, so e raised to negative x, so you have a neutralizing factor there, negative. So negative times positive is negative, so minus e raised to negative x. So this is the result of integrating or finding the integral of the first term in this equation, x times e raised to minus x dx. Now for the second term, this is just power formula, right? So y raised to n plus 1 over n plus 1. So you have minus 2 plus 1, that's negative 1 over negative 1. That's why you have this term. So negative 1, kaya naging minus yan dito. And this is the result of the integral of the first term, integral of x times negative times e raised to minus x. Now, each of these terms are negative, as you can see. So instead of writing plus c here, so we put this right-hand side of the equation, we make this also negative. And then multiplying the entire equation by negative 1, making this equation all positive, or having positive terms. Okay, do you follow? So here, as you can see, so we put this term, okay, we want to remove terms with negative exponents. So this is equivalent to x over e raised to x. And then for the second term, you can also rewrite this as 1 over e raised to positive x. And then for the third term, you have y raised to minus 1. So to make the exponent of this function positive, so you bring this down, so that is 1 over y. Now you have you have each terms with no negative exponents equal to c. Now we are ready to apply the condition here. So it says that when x approaches infinity, y is 1/2, or y approaches 1/2. Now if you apply here, So the value of x is infinity. So infinity over e raised to infinity. So e raised to infinity is actually infinity. So, and no, e raised to infinity is equal to infinity. So what happens here? And then here, 1 over infinity is actually 0. Okay, so if you remember, this e raised to minus infinity is 0. Okay, do you have any question in this term? Okay, let me just annotate here. Okay, let me just, so this term right here, bakit siya naging 0? So are you wondering? Diba? Pag sinabi natin na e raised to infinity, it's actually equal to, sorry about that, let me change color of this. So e raised to infinity is infinity, right? And then if you put e raised to infinity in the denominator, so 1 over e raised to infinity is basically equal to what? And equal actually yan sa e raised to minus infinity, right? So e raised to minus infinity is also equal to 1 over e raised to infinity, to positive infinity. And then 1 over infinity, since diba, e raised to infinity is infinity, so 1 over infinity, or a big number, too much big, is equal to what? 0. Okay, approximately 0. So having said that, so 1 over e raised to infinity is 0. So 0 times infinity is, this makes the term 0. Okay, and 1 over infinity is also 0. And then here, 1 over your y is equal to 1/2. So 1 over 1/2 is equal to 2. That's why the value of your c is positive 2. Now you plug in the value of c to this given solution. That's by giving you a particular solution equal to equal to this one. And now, and multiplying the entire equation by, what's the common here is e raised to x, and you can also multiply it by y. So multiplying the entire equation by y times e raised to x will give us the resulting equation. And what happens next is you can arrange your solution into this one, or if you're asked to solve for y, then this is your final answer. Okay, so let me explain this one. So we transpose the terms with y to the right-hand side. Okay, so this becomes minus y, and this becomes minus xy. And then what we did here is we are to solve for y. Okay, so we factor out y. So we have y times, what will remain in this term is 2 times e raised to x. And you have minus x in this term, and then minus 1. So solving for y, we now have e raised to x divided by, this function, 2 e raised to x minus minus 1. Okay, so that's it. Any question here? Questions? Clarification? Go.
So it doesn't mean any, if it was 2 all over e raised to infinity is going to still be 0. Any constant divided by infinity, e raised to infinity is 0.
Constant divided by
E raised to infinity.
e raised to infinity. So I said before that e raised to infinity is equal to infinity, right?
Like the 1 all over e raised to infinity, you got 0.
Yes. Because 1 over infinity is equal to 0. Okay?
So let's take a different number. If it was 5, will it still be 0?
What number?
Let's say we use 3.
3?
Yeah, 3.
3. As in number 3.
Yeah.
Let me write.
Yeah.
Okay, let me write for you. So it's clear. Okay, 3 over what?
Exponents raised to infinity.
E raised to infinity. Okay, so we're clear here that e raised to infinity is also infinity, right? So 3 over infinity. So 3 is very small, is a small number, right? And infinity is way big, right?
Yes.
So it's approximately, so if you are to divide, for example,
Yes.
let's have a value equal to 100, right? So 3 over 100 is 0.0. So just imagine if it's 1 million. Okay, so it's 0.00000. Yeah, the significant number there is 3, right? It's
Yes, sir.
approximately equal to 0. Okay, so
Okay.
the significant number there is negligible. Okay, because it's 0.0000. That's why. Okay, clear?
Yes, sir.
Okay. Any other questions? None? Now we can proceed to the next problem. Okay, so here, this is the given problem and this is the solution. Okay, so now let me read the problem first. Since you are given a condition here, it means that you are to find for the particular solution. Okay, so the given problem is 2a squared minus r squared times dr equals r cubed times sine theta d theta. So as you can see, the differentials involve r, dr, and d theta. It means that other letters that you can see there are considered constants. Okay, so the variables involved are theta and r. It means that a here is considered a constant. Okay, so even if it's not mentioned that, let me wait for a moment. Okay, even if it's not stated that a is a constant. So as you can see, when theta is equal to 0, r is equal to a. So we'll use this later after we have determined the general solution. Now, what we're after here is to separate the variables, since that's the only method that we have learned yet. Okay, kayo pala, that you have learned yet. So let's try to separate the variables. And here, as you can see on the left-hand side, this is already a pure function of r, right? So on the right-hand side, you have a function of theta multiplied to r cubed. So what you need to do is to remove r cubed in this side of the equation. So we divide both sides by r cubed, giving us this resulting equation. Now that we have this, the right-hand side is a pure function of theta, okay, sine theta d theta, and the left-hand side is a pure function of r. Now we can divide each term by r cubed. That's why we have this two terms here. So 2a squared times dr over r cubed minus the second term is r squared divided by r cubed. You can actually cancel r squared. That's why we have this term dr over r. And you can also put this r cubed up, making the exponent negative. So you have, or you can put this 2a squared, since this is constant. You can put this before the integral symbol. So you have 2a squared integral of r raised to minus 3 times dr. And this term is integral of dr over r. And the right-hand side is integral of sine theta d theta. Okay, so using the power formula, you will now have r raised to minus 2 over minus 2. And this term is minus ln of r. And the integral of antiderivative lang to, diba? Integral of sine theta is minus cosine theta. And then you are to add the arbitrary constancy or plus. Okay, in this case, we did plus ln of c. So, okay. So what's next here? So we put this plus ln of c. It means that we are to remove the logarithmic function. Okay, we are to make, we are to transform the solution into completely having no logarithmic function in it. Okay, so we are going to rewrite now here. Um, okay, so 2 divided by minus 2 is negative 1. So you have negative a squared r raised to minus 2 minus ln of r equals, okay, this equation. Now the next step is we will transpose this term with ln to the right-hand side so that we can combine them. And then we transpose this cosine theta to the left-hand side to make this positive. So you have cosine theta, positive na siya, minus a squared. So you can bring this down to make the exponent positive. So you have a squared over r squared equal to, so this can be transformed into this resulting logarithmic function. So ln of c times r. Now, what's next? So what you will do here is to, or you may either, yeah, you may put it this way, or pwede mo na siyang anti-ln just like what I'm doing. So you anti-ln, you put this exponential e raised to this entire term and e raised to ln of cr. That's why the resulting solution here is c times r. And we now have this one. So e uh, raised to cosine theta. Okay, you may remove this solution, this part of the solution. Okay, so what we did is we did anti-ln. Okay, so let me just um, erase or put a mark that you can remove this step. Okay, so you may or may not follow this one. Okay, so once that you have done this part, you can proceed to making this anti-ln. So let me just write, okay, e raised to something and e raised to this function. That's why you have this result. Okay, clear tayo? And the next step is we express this equation so that we can isolate C, since we are after for solving the arbitrary constant because of the given condition. Now that we have written the equation into this format, then we plug in the initial conditions, theta is equal to 0 and r is equal to a. So we plug it in here. So you have cosine theta. Okay, cosine theta, theta is equal to 0. So cosine of 0 minus, you have a squared over r squared, and r is equal to a. So r squared becomes a squared. You could actually cancel this, right? A squared divided by a squared is equal to 1. And cosine theta in radian measure is positive 1. Now 1 minus 1 is 0, and e raised to 0 is equal to 1. That's why the value of your C is 1 over A. Okay, do you follow? Now that we have the value of C, we plug it in the general solution. That's why we have this particular solution. And you can also express your answer solving for R. Okay, multiplying the entire, or you do cross multiplication. So you multiply A to this side of the equation and R to this side of the equation. So you have R equal to this expression. Okay, so that's it. So this may be your final answer. Okay, so this is just written in this format because in the book, this problem is found in the book that I have shown you, written by Rainville and Bedient. Okay, any questions, guys? Any clarification about the solution that you want to ask? Who knows if this may come out in your exam. So make sure that you understand each step of this. I might be asking, some of the terms or some of the items here. Any question? Go ahead.
Pero yung ask ko lang po i-upload rin po tong video sa Embro. So simuubos sa payload ko po.
Oh, okay. Sorry about that. So, pwede ka namang mag-leave. Okay, naka-record naman to. Anyway.
Sige po.
Okay, sige. Any other concerns, guys? None? Okay, now let's proceed to the next problem. Let me just erase this one. You're all drawings. Okay. So the next one is involving trigonometric functions. So yeah, we have sine of x times sine of y dx plus cosine of x cosine of y dy equal to 0. Okay, I know this is just an easy problem, so let's just solve anyway. So we can separate the variables. Okay, we want to remove function of y here because the term here involves dx. And here, the term here involves dy, so you want to remove the function of x here. So dividing both sides by sine of y times cosine of x will give us, okay, this resulting equation. Okay, a pure function of x and a pure function of y. Okay, sine of x over cosine of x is equal to actually tangent. So you can actually express it into tangent. Okay, and cosine of y over sine y is cotangent. Or you can directly integrate using the logarithmic formula. Okay, that's the other way. Or if you know the antiderivative of tangents, you can directly, answer that here. Like you can say it's ln of or minus ln of cosine x, or you can say ln of secant x, since cosine raised to -1 is, let me just write annotation here. Just a review of trigonometric functions. Okay, the reciprocal of cosine of x, do you know? So cosine of x, right, is equal to 1 over, yeah, secant of x. And for sine of x, okay, the reciprocal of, yeah, sine of x is actually what? I mean, sine of x equal to the 1 over cosecant of x. So this part right here can be expressed into what? ln of secant x. Okay? Okay, because I'm showing you because there might be other answers. Okay, but they're the same actually. If you are to plug in some values for their argument. Now that we have this, so this is your u equal to cosine of x, and this is your du, and the derivative of cosine is negative sign. So you have a neutralizing factor of negative. That's why we have minus ln of cosine of x. And if this is your u sine of y, your du is differential of sine y is cosine y dy. So it satisfies the formula that we can say ln of sine of y is the answer to this integral. And then you put this term here. You have an arbitrary constant, which is ln of c. And then you can combine, okay, you can combine these two terms. So this means ln of sine y minus ln of cosine x can be written as ln of sine y over cosine of x. So now that both sides of the equation have ln, so we can take the anti-ln both sides of the equation to remove the logarithmic, the ln function. So we have now this resulting equation, okay? Or you can say sine of y is equal to c times cosine of x, okay? So that's it. Questions? Clarification about trigonometric functions? Do you want to review? None?
Sir, pa-review po nung negative ln plus l. Paano po naging yung nag-isa sa baba?
Wait. Saan po?
Yung negative ln cos plus ln sin po. Tapos yung value niya is yung nasa baba, yung ln sin y over cos. Paano
Okay.
po yung nagiging? Pa-review po.
Sige, sure. So, if you remember this, yan, kung mapa-ln man yan or logarithmic function na, okay. Wait lang. Let me erase that. Okay, so for ln of x minus ln of y, property, okay, a logarithmic function. So this is equal to what? Yung positive part, yun yung magiging numerator mo. And the negative part will be the one in the denominator, okay? And if it's plus, they will just be multiplied, okay? Plus ln of, so there are many variations actually, yan, equal to ln of x times y. So kung ito lang yung gusto mong tandaan, pwede naman. So pwede mong gawin to as what? So gusto mo maging positive yan, di ba? So ln of, kung ito lang yung naalala mo. For example, so ln of x. So you make this positives. How do you do that? Plus ln of y raised to negative 1. Diba? Kasi the property ng logarithmic function, pag sinabi natin kung minus yan, minus 1, a ln of b is equal to this coefficient right here can become the exponent of the argument on the logarithmic function. That's why this is what ln of b raised to a. So the coefficient here is minus 1, so you can put this in this way, in this form. That's why. So kung ito yung naalala mo, you can make this actually x times y raised to minus 1. Diba? And since negative yung exponent nito, pwede mo siyang gawing positive by bringing this down or putting this down. So magiging ln of x over y. So paikot-ikot lang. Ganun.
Salamat po.
Okay, ganun yung nangyari dito. So ito yung may positive part, right? So ito yung magiging numerator, right? Sine of y. And this one is yung may negative na coefficient. That's why ito yung nasa denominator. Okay? Clear? Sige.
Sir, pwede pang tanong.
Go ahead.
Yung sin y over cos x po equals c, yun na po yung final answer, sir.
Sin y equals?
Sin y over cos x equals c, yun na po yung final answer sa baba. Or
Yeah.
pwede rin po yung sa pinakababa.
Sure. Yan. Nakita ko lang na pwedeng ganito yung final answer mo, or you can actually answer this one. Lalo na kapag...
Bakit po nililipat yung cos x sa right hand side, sir?
okay.
Po.
So pwede naman gawin yan. So we want that parang isang line lang siya. No other, walang fraction na walang somehow parang rational expression or fraction sa mismong sagot mo. That's why we want that na isang line lang siya. So kapag gano'n na fractions, na may fraction na involve na expression, so we wanted to make it what? Hindi na walang fraction sa mismong answer natin. So that's why. So how can you be able to eliminate cosine of x here? By multiplying or by doing cross multiplication. Diba? Alam mo yun? Cross multiply.
Okay na, sir. Naalala ko.
Pag nag-cross multiply
Sige po.
ka, x over a equal to y over b. Yan. Cross multiply lang tayo. Ganun lang yun. Okay? So ganun nangyari. So kunyari c over 1 yan dyan. So 1 times sine of y. So ganun lang. Parang isang line lang siya.
Thank you po.
Okay. Any other questions? Sure.
Sir, yung final answer po, pwede po ang gawing in terms of y.
In terms of y, okay, solving for y, right?
Opo.
So, ang mangyayari dito if you're asked. So, pwede mo lang gawin yun. Lalo na kapag known na kumbaga yung arbitrary constant mo. Okay? So, pwede rin naman. Sige. So, magiging ano siya, guys? Y is equal to, kunin mo yung inverse nito, right? So, magiging arcsine. No?
Opo, sir.
Yan, magiging arcsine siya. Yan, C cosine of x. Okay. So ito, solving for y kapag ganun yung case.
Thank you po, sir.
Any other questions? So ito lang yung mga other forms of your answer. So if you're asked to solve for y, so you can express into this format. So pwede na rin ito. Pero kapag ganito yung sagot mo, so this is not yet simplified because of the ln. Right? So we wanted to na hindi parang doble-doble. Ito yung ln, ito yung argument niyan. So medyo komplikado siya. So kaya kapag simplified, na kapag nag-apply ka, if you apply the conditions, so it will not be difficult for you to determine, the value of whatever the unknown or parameter that we want to solve. Okay, so since you have may tanong pa ba? None? Questions? Sure. Let's proceed to the next problem. Okay, it's almost 8. Okay, so this one here is somehow similar to, okay, let's try to. So I have, if I could still remember, so this problem has been one of my favorite problems to give in a quiz or in the exam, because students sometimes are, having difficulty with, especially if I'm using, letters as constants. Okay, as you can see, we have you have B there, and you have theta, and you have R. So just be careful. Okay, so B here is a constant, okay? Because we have differentials dr and d theta only. So it means that the variables involved are theta and r. So other than that, constants yung mga ibang letters that you can see in the problem. So yeah, so I can say that when I give this in the exam, so there's a sure person that will mess this up. Anyway, so I hope it will not happen to you. So if I'm going to give you an equation involving constants that are letters, okay? Like A, B, C, like that, or other letters. So here, what we'll do here is, okay, we can distribute B in each term since, okay, take a look at this one. B is a constant, right? So um, we want to separate the variables. So before that, it's okay to distribute B because B is a constant. So we have B cosine theta dr plus second term will be B times R sine theta d theta. So what you want is, since dalawa yung dr, there are two terms with dr. So you can transpose this term to the left-hand side so that you can factor out dr. And you have a coefficient which is 1 minus B cosine theta. Now, again, B is a constant. Okay, so this function is a pure function of theta, remember? And now on the right-hand side, you have B times R sine theta d theta. So R here is the other variable, and you want that this term will be a pure function of theta. That's why you want to remove what? R in this side of the equation. You want to remove this expression here, 1 minus B cosine theta. So dividing both sides by R minus 1 minus the quantity, 1 R times the quantity 1 minus B cosine theta, sorry. So ito na yung maging result. So dr over R equals B sine theta d theta over 1 minus B cosine theta. So as you can see here, this is pure function of theta and pure function of R. Then we integrate both sides of the equation. That's why we have ln of R equals, and then you have to check this one. Okay, I think may pumapasok pa. Okay, now we will check this one. So our U here is B. Let me just annotate. Let me just get my pen so I can write something. Okay, so we will use the logarithmic formula. Okay, I mean the integral of du over u. So our u here is this expression. This is our u, and this should be our. I'm sorry about that. Wait. This is u, and this will be du. Hopefully. So if you have to differentiate this one, b, so you have du will be equal to, so you just copy the constant minus b, and then differentiate cosine theta, and that is negative sine of theta times d theta. So as you can see, if you multiply negative b by negative sine theta d theta, so it will become positive b sine theta d theta. It means that the numerator here satisfies as the differential of our denominator. Okay, so then this is the result of integrating that or finding the integral of that right-hand side of the equation. Now that since ln sila, ln, so you can make the plus c ln to simplify them. So you can combine them into one term. So you have c times 1 plus 1 minus b cosine theta. And then you can now apply the anti-ln both sides of the equation. That's why you have r equals c times 1 minus b cosine theta. Okay, so that's it. Any questions here or clarifications? None? People? None? Okay,
None
Okay.
po.
great. So we have now the last problem. So I think you are interested to solve this one. So I think I have shown you this one, how to separate the variables. So this is done by factoring by grouping. Okay? So pwedeng hindi na naka-equate to 0 yan. So you can remove equal to 0 here. Okay, so again, I have shown you this before. So let's just review again. So x times y. Okay, so you have a common factor here. Okay, so this is x. So you factor out x. So you have this expression in the left-hand side. So x times y plus 1. Okay. Mm. Now, here you can factor by group. So you put this into a one term. So x squared y squared plus x squared. And you can actually, wait for a moment. I'll just get my pen. Okay, so you factor by grouping. So you can make this as one term. Okay, now that we have put in this format. Okay, so what's common in the first term is what? You have x squared. So you can factor out x squared. And here you have y squared plus 1. And then sa second term natin, you also have y squared plus 1. Ayan, so you can factor out y squared plus 1, giving us this expression. And then you have x squared plus 1. Okay, so naka-factored form na sila. And we can separate the variables now. Okay, so you can remove this part of the equation. Kahit wala na yan dyan. Tanggalin mo na yan. Okay, so here, so to remove the function of x here, we divide by x squared plus 1. And to remove function of y here, we divide by y plus 1. That's why we have this resulting equation, x dx over x squared plus 1, a pure function of x, y squared plus 1 times dy over y plus 1. This is pure function of y, so you can integrate this one. So this can be solved by long division. So y squared plus 1 divided by y plus 1 is equal to y minus 1 plus, of course, you have the remainder there, 2 over y plus 1. So this rational expression is equivalent to, okay, after you have done the long division, you have y minus 1 plus 2 over y plus 1. Okay, now, so tatlong terms yan. For this side of the equation, you can actually utilize, okay, the logarithmic result, the formula. Okay, so we have 1/2 ln of x squared plus 1. Okay, why 1/2? This is 1/2 here is the neutralizing factor, because what you need in the numerator is for this to become the differential of the denominator x squared plus 1, it should have 2 here. So you introduce 2 and then you neutralize outside by dividing it. Okay, you have a constant here, 1/2. So why the answer here is 1/2 ln of x squared plus 1. You have 3 terms here, so you can distribute dy. So we have y dy. The next term will be dy or minus dy, and then the last term will be dy over y plus 1. So you put the constant before the integral symbol. So integral of y dy is y squared over 2, or 1/2 times y squared. Integral of minus integral of dy, so you have minus y. And here, so you copy 2 and then integrate dy over y plus 1 is ln of y plus 1. Now to simplify this equation, so instead of writing plus c, you make c as ln of c, and then to eliminate the 1/2, you can, okay, or you can actually multiply the entire equation by yeah, to make this 2 ln of c, and then you divide both sides, or you multiply both sides by 1/2 now. So here, multiplying the entire equation by 2 will give us ln of, yeah, x squared plus 1. And then here you have y squared, and here you have 2y plus, and then 2 times 2, you have 4 ln of y plus 1, and you have 4 ln plus c. So that you can combine this one. So factoring out 4, you have now ln of y plus 1 plus ln of c, and you can make this into, you can put this into one term by writing as, 4 ln of the product c times y plus 1. Okay, so here, just the same. And you can also combine this ln to this part right here. Pwede naman yan. Let me just show you. Okay, so what's more appropriate? So if you have y squared in here, or if you want to put in one side of the equation, so pwedeng ito na. Yan guys. So you have y squared, and then you have minus 2y. What you're going to do is transpose this term to the right-hand side. It will become minus, right? So this will be, let's say, so plus ln of, you have c times y plus 1 raised to 4, and then minus, ln of x squared plus 1 equal to 0. But you have to put this inside the parentheses. And then you can combine them. So this will become, so, kaso maging ano siya, isang term na lang, di ba? So c times y plus 1. We just follow the raised to 4 over x squared plus 1 equal to 0. You just copy this one. Yeah, y squared minus 2y. Okay, so that's it. So you can have an answer like this, or you can have an answer like this one. Any question? Question? None?
Paano po naging 2x yun, sir? Yung sa may dos, x over x dx over x squared plus 1, tapos naging 2x dx over x squared plus 1.
Where? Saan ba? 2x dx. Saan guys? Saan? Yung sa x dx? Ito? Ito ba?
Yes, sir.
Paano naging? The question is?
2x dx over x squared plus 1. Paano po naging?
Oh, okay. So if you can see this one, diba, yung 2 divided by 2 is still 1, right? So, ganun pa rin yung x dx over x squared plus 1. So, the question is, bakit naging ganito? Since ln yung result niya, okay, wait lang. I'll just get my pen. So, if, diba, we utilize the formula du over u, diba? So, if our u is equal to, yung denominator natin, diba, x squared plus 1, our du will be what? If you differentiate this, so 2x dx, right? So that we can utilize the formula, which is ln of, if you integrate this one, it will become ln of u, of the denominator. So we cannot do that if it does not satisfy the differential at the numerator. So we need what? 2 in the numerator here. So you can put 2 here, and then of course, you neutralize that, okay, by dividing outside by 2. So ganun lang yun. Or you can do substitution, di ba? Yung x dx is equal to what? du over 2. So, ganun lang yung kaya may 1/2 ka dyan. Nakuha mo? So, 2 divided by 2 is 1.
Thank you po, sir.
Okay, any questions? None?